Now, next thing that I wanted to talk about a little bit, and I really like to start with this. So this was more of an, anatomical, functional approach to digestive activities. What I wanted to discuss is the regulation of digestive activities. By regulation, like general approaches, how all the digestive activity is regulated, and it's obviously going to be negative feedback, And as for any process that's regulated by negative feedback, we are looking at the stimulus, right? The response and the effectors of this response. So if we start with the stimulus, I think we talked about it in AP1. What is the stimulus? What is the stimulus for the B2? What's the stimulus for digestive system always? Food. So in one form or another, there's food. And when we use term food, of course, we're not necessarily referring to, an apple being an apple within the stomach or intestine. It's already not an apple. And then you've got what kind of response you essentially can issue towards the food.
Salivation.
More broadly, just one word. What do you need to do with the food?
Digest.
That's it. Any kind of, so basically, response is going to be digestion. Like big time digestion. And what are the effectors that carry it out? You have two options always, muscles and glands, right? So you have glands, salivary glands, pancreas, liver, or smooth muscles. So in this scheme of things, if you think about it here, glands will release digestive juices. Saliva in the mouth, gastric juice in the stomach, pancreatic juice, if you're talking about intestine and all that kind of stuff. And smooth muscles will do peristalsis to move the food, they will do segmentation, you're going to do there's some skeletal muscles involved, of course, you're chewing on the food. So far, does that make sense? Now, the regulation of this process, this response can be two-part. It can be through the hormones, which we'll talk about, separate story, okay? Or it can be through nervous system. So the big question, of course, when it goes from, so what does stimulus stimulate? What kind of, what branch of nervous system? I'm going to give you a hint. So obviously it's going to be CNS, of course. It's going to be, generally speaking, central nervous system. But which branch is it going to be? Is it going to be somatic or autonomic? Think about the control. Remember, somatic you have a control over.
Autonomic.
Exactly. So I'm going to demonstrate there's a little tiny involvement of the somatic nervous system, of the conscious branch, into digestive regulation, but mostly it's going to be autonomic nervous system, right? And then you're going to have the response. Now, at which levels, structural levels, this response can be generated? I'm sorry. So, since we aren't talking about, somatic, cerebral cortex is basically out of equation, right? Turns out practically all digestive activities are in the brainstem, more specifically medulla. Okay. So you will have food basically sitting in the stomach, right? And then distension of the stomach will go as a nervous signal to the medulla, and then medulla will produce motor response that will be directed towards the stomach, secretion, or peristaltic responses. Now I'm going to check whether or not you remember chapter 3 of AP1. Which nerve is it going to be? Which nerve communicates between the brain stem, it's a cranial nerve, brain stem and the stomach, small intestine, liver, all those organs, and the abdominal cavity. Organ that controls almost all organs. The nerve that controls almost all organs.
The vagus?
Yeah. So basically all digestive response, well, many digestive responses will be controlled through the vagus nerve, and it will be not just vagus, it will be parasympathetic responses, right? Remember, rest and digest. So generally speaking, parasympathetic stimulations will increase digestive activities, right? And sympathetic stimulations, generally speaking, will slow them down. This is why, that advice, you had a lunch, don't go exercising even in an hour, because sympathetic activation during the exercise will slow down the digestive processes in the stomach. Now, another interesting feature, we have gigantic intestine, like really, really, really long. And if you fathom how to establish the innervation to all those different parts, come on, it's not feasible. Like, you can't have so many branches. It's just too bulky, too cumbersome. So what happens actually, we have so-called enteric plexus. It's not just one plexus in one little part of the stomach or the intestine. It's found all throughout the intestine and the stomach in submucosa and muscularis. And sometimes it is referred to as a gut brain. So look what can happen. So you can have stimulus, check this out. Stimulus can go to the CNS, right? That makes sense? Brain stem back to the organs. Or it can stay entirely within the organ. So stimulus will be perceived and integrated by the local nerve plexus. And that local nerve plexus will produce the response without the involvement of CNS. I mean, it doesn't mean that it doesn't have to. So certain responses will be local. Does that idea make sense? It's kind of a unique situation because in most cases, you may remember, autonomic reflexes, they have to involve CNS, they have to involve medulla or pons, Is that clear? Okay, great. Now, what about the involvement of cortex? So generally speaking, we can't control our digestive activities. You can't just order your stomach to not digest food, right? And there's probably a food that you like, I don't know, chocolate, whatever, beer, bread. If I will bring it to you now, this food, you will have a salivation response right away. But there's probably food that you don't like really don't like. And if I will bring it to you, you aren't going to have that salivation response. Whether or not you like the food, that's your cortex. Moreover, you can basically, like if I think about, well, I had lunch recently, so it's not that effective, but imagine that you're really, really hungry and you're driving home and you think about pasta, that is waiting for you on the stove. Just thought of it, just, you know what it tastes like, what the smell is like, it stimulates. So basically some cortical, some conscious stimuli can evoke certain digestive responses. Does that part make sense? Good? Any questions? Okay.